In this lesson, I'm going to help you to understand a concept associated with cloud architecture called loose coupling. And before we get to loose coupling, let's see what tight coupling is. So this is kind of the opposite, and it's really what you don't want to do if you can avoid it. So in a tight coupling scenario, we have a web tier. So this is your web service, your website, your web application. And then you've got the app tier. So the app tier is what's going to process information. So maybe your connections come from your clients to your web server. They submit some information. It gets processed by the app tier. So what's going to happen in this situation is the web service here is integrated directly with the app tier. So when those connections come in, those messages that need to be put across to the app tier, they're sent directly to the app tier from the web service here. So we've got all of these messages coming in that then need to be processed by the app tier. Now, what happens if your application scales and you've got a lot of connections coming in, it's a really busy day, and your app tier suddenly can't handle the load? So it's suffering, it can't process the information. Well, in some cases, that could mean that the app tier fails in some way, or at the very least, it's going to drop those messages and it's going to miss important information. That could be customer orders, for example. You don't want to miss those. So that's a situation you want to avoid. And how can we go about doing that? Well, we introduce something in the middle between the web tier and the app tier, and this is known as a message queue. In this case, we have the producers, and that's the web tier. So the producers will send messages to the queue. So we've got our messages coming from our web tier, and they're getting put into the queue. Now, the thing is, what can happen is you can just keep sending messages into the queue, and they're going to just sit there and await processing. So what this means is you no longer have the app tier becoming overloaded, because the app tier can check in its own time. So the app tier can then go and poll the queue for messages. It checks, yep, there's a message, I'm going to process that one. It asks for another one and processes that, and so on. And that means that the app tier can process the messages, and it doesn't become overwhelmed. It doesn't become overloaded and fail. And the messages don't get lost if the app tier can't keep up with the speed that the messages are being produced by the web tier, because they just go in the queue, and the queue can hold a lot of messages, and they'll be polled whenever your app tier can do it. So this is called loose coupling, because you're separating your tiers of your application and you're placing something in the middle, which means you're not integrating your web tier to your app tier. You're integrating your web tier to the queue and your app tier to the queue, and it acts as a kind of buffer. So that can really help with scaling your application, ensuring your systems perform, and it helps as well if something fails, because for example, your app tier might be processing a message from the queue, but then it fails. Well, the message will actually reappear in the queue in many cases because it wasn't actually completed. And in that case, another app tier instance can actually then go and process that message. So there's quite a few advantages to using loose coupling.